I kept this one on here because I think Cheby's might be on the exam. And Cheby's is the non-parametric version of empirical rule. It's when you don't know it's normal. And Cheby's tells us one standard deviation out, we know nothing. Two standard deviations, we're picking up at least 75. Three, we're picking up at least 89. Empirical is better. One standard deviation, we're picking up approximately 68. Two, approximately 95. Three, almost all. But empirical requires normality. This one doesn't say anything about normal. So I'm going to set it up as Cheby's. And here's what I'm going to do. I don't know anything here. One standard deviation, I know nothing. Two standard deviations, I'm picking up at least 75. And three, I'm picking up at least 89. And on this one, I'm going from 45 to 65, so I'm picking up at least 75. If it was empirical, it's two standard deviations out. I'm picking up approximately 95. Looking at this next one, I know that it's strong, linear. If R would be close, it's positive. R would be close to 1. Best answer is the first one. For 13, the strongest is the R value, that the correlation coefficient that's closest to either -1 or 1. And that would be the strongest one. This one, you're going to go to the calculator and you've got a line of best fit and you're going to substitute in 1.1 for the nitrate level. So I'm going to do 2.789 plus 10.39 times 1.1. I don't really like the parentheses on the little calculator, but I come up with 14.218. If it doesn't say to round, don't round it. Type it in just like that. 15 is slope. Here's my definition of slope. As diameter increases by 1 centimeter, volume is predicted to increase by 0.05 cubic meters. Best answer, and they all kind of look right, so be careful. Best answer is for every 1 centimeter increase in tree diameter, the volume is expected to increase by 0.05 cubic meters. A probability distribution, all of the probabilities P of X have to be between 0 and 1, and they have to sum to 1. I see that negative P of X, so that's not legitimate. It doesn't matter about X, it matters about P of X. The probability can't be negative. This one is expected value. Don't round that, but just type it in like it is. And I'm going to type it without parentheses. And I come up with 1.8. And I'm not going to round because it's expected value. On 18, it's binomial. And I want the mean, so it's 12 times 0.08. And what that's going to give me is 0.96. And on the next one, I want the standard deviation. I'm going to do the variance first. So it's 0.96. I've got that from question 18 times 1 minus 0.08. All right, so it's this one I'm going to use the parentheses for. 0.96 times the quantity, 1 minus 0.08. All right, now for the answer they want standard deviation. So I need to take the square root of that. So I'm going to do the square root of 0.8832. And you don't want to do any rounding until the end. I want the square root of 0.8832. And there's what I get. And I want 4 decimal places. So my final answer is 0.9398. The last one, it would be a question where we could use normal CDF, but you're not using the calculator. So I drew out normal curves for each of them, and you want to know which one the probability has to be less than 0.5. So you all know 40 is where 0.5 is. So if you look at that first one, that's less than 0.5. If you look at the next one, greater than 30, that's more than 0.5. Less than 42 is more than 0.5. And less than 50 is more than 0.5. So it's the first one that is greater than 42.